Hi guys. Today we're going to start algebraic methods of solving quadratic equations. Lesson 32-1, the square root method. Learning targets. Solve quadratic equations by the square root method. Provide examples of quadratic equations having a given number of real solutions. Wynn is trying to build a square deck around his new hot tub. To decide how large a deck he should build, he needs to determine the side length, x, of different sized decks given the possible area of each deck. He knows the area of a square is equal to the length of the side squared. Using this information, Wynn writes the following equations to represent the decks he is considering. Item 1. Solve each equation. Be prepared to discuss your solution methods with your classmates. Now, math tip. A solution of an equation makes the equation true. For example, x plus 5 equals 7. The solution is x equals 2 because 2 plus 5 equals 7. Item number 1A. X squared equals 49. So we're looking for the possible answers that would make this true. And of course, the answer is that the number that you can square to get 49, of course, is going to be x is equal to 7 and x is equal to negative 7. Because when x is equal to 7, 7 times 7 is positive 49. When x is equal to negative 7, then negative 7 times negative 7 is also positive 49. All right, so for B, it's a similar kind of thing. We're looking for the values of x, that when we square it, we're going to get 100. And again, that's going to be x is equal to 10 or x is equal to negative 10. And then as we continue on, we look and we say, okay, well, that seems pretty easy. So let's go ahead and look at the next one, C. So how can we think about, well, what number times itself equals 15? Well, it's kind of hard to think about numbers, so we just think about what we have to do. So we're thinking about x squared, and we want to make that x. So in order to do that, we take the square root of it, because the opposite of squaring something is the square root. So that's going to be x. And then we recall that what we do on one side, we have to do the same thing on the other side in order to keep it equal. And so that's going to be x is equal to the square root of 15. We also think of it, this is also, if the others were the positive or negative versions, and this, of course, can also be x is equal to negative square root of 15. So let's look at D. D, we have 2x squared equals 18, and we don't want to jump to the square rooting until we've kind of got the x squared by itself. So therefore, we have to, of course, divide out the 2, and we get x squared is equal to 9. And so if we take the square root of both sides, we found out that x can be equal to 3, or x can be equal to negative 3. Now the rest, we're just using our standard algebraic rules to go through here. E is x squared minus 4 equals 10. Again, I'm trying, that's actually 0. I'm trying to get the x squared by itself, so I have to go ahead and add 4 to both sides. So that's going to be x squared is equal to 4, which we know x can equal to 2, or x can equal to negative 2. And so the last one, we look at that, and it's not a perfect square, but we can still do it. We have our x squared plus 2 equals 0. And so we're going to go ahead and subtract 2 from both sides. And actually, I don't think we can do this because we're going to end up with an imaginary number. We end up with x squared is equal to negative 2. And there's no number that we know of, no real solution that if we square it, we'll be able to get a negative value. So that's going to be, in this case, no real solution. We don't want to say undefined or no answer we'll say no real solution. Because using imaginary numbers, we can still work it out. But that's for another time. And so that was for F. Okay, so let's go ahead and look at G. G is x squared plus 3 equals 3. So we're going to subtract 3 from both sides to get the x squared by itself. And the only number, of course, we could multiply times itself to get 0 is 0. So x is going to be equal to 0. And there's no positive or negative version. So it's just that one answer right there. Item 2. Refer to the equations in item 1 and their solutions. What do the equations have in common? So what do they have all in common? Well, they're all quadratic equations. They all have an x squared, or a variable squared. B, what types of numbers are represented by the solutions of the equations? Well, we end up with all real numbers, or all of the answers are real numbers, with the exception of that one that has no real solution. The answer there was actually an imaginary number. But we don't know how to do that yet. So we'll get to that in another course. And C, how many solutions do the equations have? Well, most of them have 2, a positive and negative version, with the exception of one that's x is equal to 0. Okay, and of course the one that's no real solution. And D, reason quantitatively. Which solutions are reasonable for side length of the squares? Well, a side length is a distance. And the question is, well, can we have a negative number as a distance? And you're all sitting there right now going, no. And so that's true. We cannot have negative numbers. So the only ones that make sense, even though mathematically you have positive and negative versions, the only ones that make sense to answer the question is the positive numbers. To solve a quadratic equation in the form ax squared plus c equals 0, then you're going to isolate the x squared term and then take the square root of both sides. In other words, if you don't have the middle term, if you don't have a term with just an x, then it's just real simple. You isolate the x squared and then take the square root of both sides. So for example, example A, we're going to solve 3x squared minus 6 equals 0. So there's no middle term, so we're going to focus on getting the x squared by itself and then just taking the square root of both sides. So that just means we need to get x squared by itself. So in this case, we're going to add 6 to both sides. So I have 3x squared is equal to 6. And then I'm going to divide both sides by 3. And this is your basic algebra. And so x squared is equal to, well, that's going to be 6 divided by 3, which is 2. So the answer is going to be x is equal to, we're taking the square root of both sides. So x is equal to square root of 2, or x is equal to negative the square root of 2. So it's been or instead of an of, and because I found my eraser, I'm going to go ahead and use it. There we go. Okay, so let's go ahead and do some of the try these. Try these A. It's asking us to solve each equation using square root. So we're using the square root method. We notice that we have a term with an x squared, but we do not have a term with just an x. So we can use the square root method. And so for the first one, we have x squared minus 10 equals 1. And so we're going to go ahead and take get x squared by itself. So we're going to go ahead and add 10 to both sides. So we get x squared is equal to 11. And we're going to go ahead and take the square root of both sides. So we know the square root of x squared is x. The square root of 11 is, well, it's not a perfect square, so we just leave it as the square root of 11 for now. Or x is equal to negative square root of 11. Okay, I'm just going to erase that and write it a little bit later. x equals negative the square root of 11. I said we're just going to leave that for right now. We do want to remember that if the radical that we end up with here is not a perfect square but can be simplified, we'll want to simplify it. But since it's the square root of 11, that can't be simplified because 11 is a prime number. But we will be simplifying these if they can be simplified. All right, so let's go ahead and do the next one. I'll do it in a different color here. Okay, so the next one is x squared over 4 is equal to 1. And you can think of this as two things. You can think of it as x squared divided by 4. So the opposite operation is to multiply both sides by 4. That's probably the easiest way. Okay, or another way to think about this is also could be rewritten as 1/4 x squared is equal to 1. And then you would multiply both sides by 4 over 1. But remember, you're multiplying by the reciprocal. And 4 over 1, of course, is just 4. So we have x squared is equal to 4. And we take the square root of both sides. And that's going to be x is equal to 2, or x is equal to negative 2. All right, and the last one on here is 4x squared minus 6 plus 14. And again, they're just, no, that's not right, equals 14. Okay, so again, we're just trying to get x squared by itself. And so if you notice, they're adding more and more numbers and things like that, but it's all the same thing. Just algebra, just trying to focus on getting x squared by itself. So we're going to go ahead and add 6 to both sides. That's going to give me 4x squared is equal to 20. And then I'm going to divide both sides by 4. X squared is equal to 5. And then we take the square root of both sides. X is equal to the square root of 5. Or x is equal to negative the square root of 5. Number 3. Quadratic equations can have 0, 1, or 2 real solutions. Fill in the table below with equations from the first page that represent the possible number of solutions. 2 solutions, you can pick almost any of them. You know, the example would be like the first one was x squared equals 49. And the reason why is we ended up with x is equal to 7 or x is equal to negative 7. So we ended up with 2 solutions. X is equal to 7, x is equal to negative 7. Okay. And then one solution was the situation where we had like the x squared is equal to 0. So if when we go ahead and work it out, we get 0, then that would be the case. So the example of that, of course, would be when we had the x squared plus 3 equals 3. And of course, we subtracted 3 from both sides. We ended up with x squared equals 0. So the only answer would be x is equal to 0. So that was the one solution. And the no real solution is when we had our x squared and it ended up equaling a negative number. So we had x squared plus 2 equals 0, and we ended up with x squared minus 2. Okay, x squared equals minus 2. All right, so item number 4. Reason abstractly. A square frame has a 2-inch border along 2 sides as shown in the diagram. The total area is 66 inches squared. Answer the questions to help you write an equation to find the area of the unshaded square. Okay. So we know this whole thing is 66 inches squared, or square inches. 66. And what we're doing is we're kind of trimming off 2 inches. We're trimming off 2 inches just on 2 faces. Okay, so what we can do though is we kind of think of what we're doing here. We're really just multiplying these 2 things here. So we're multiplying our x plus 2. Well, let's do this the way the book wants it. So A, it says label the sides of the unshaded square. So the sides here is, this is going to be X, and this is going to be X. So those blue X's I don't think are in your book, but that's what they are. That's X represents an unknown value. So we don't know what this is going to be. We know the whole thing is 66 square inches, and we know we're shaving 2 inches off these two faces here to keep it to be a square. All right. So we went ahead and did this. So B says fill in the boxes to write an equation for the total area in terms of X. So in terms of X, the total area is going to be this X plus 2 times X plus 2 equals 66 inches squared. And that's going to be the equation that we have here. Of course, we can rewrite this as X plus 2 squared equals 66 inches. All right, so now we can go ahead and solve this one in the same manner that we did before. Oh, well, what is that manner? Well, here's the thing. If we just think of this as being a variable squared, like for example, we could say A equals X plus 2, for example. In that case, this would be A squared equals 66. Now, in that case, what we would do is we would take the square root of both sides. But we can do the same thing here. We take the square root of both sides, and we can say, okay, the square root of something squared is what it was squared. So it's going to be X plus 2 is equal to the square root of 66. Right. And then to get X by itself, we're going to have X is equal to the square root of 66 minus 2, because I subtracted 2 from both sides. Or it could be X is equal to negative square root of 66 minus 2. Well, obviously a negative minus a negative more is going to be a negative value, so that one would not make sense. But it is one of the solutions. So we have our 66 minus 2 and our negative 66 minus 2. But the only positive answer is going to be this. And if you do this on the calculator, as shown on the example, it's going to be X is equal to 10.12, actually negative 10.12, or X is going to be equal to positive 6.12, and of course the solution we would pick would be the positive one, because the negative one does not make sense. Okay, try these B. Solve each equation using square roots. So in this case, we think about this and we say, well, I have X minus 5, all that squared, and that's equal to 121. So what I can do here is I'm going to pretend that this is just one thing. So I'm going to take the square root of all that, the square root of that. So the square root of anything squared is what was in there. Square root of 121 is 11. And then, of course, X minus 5 is equal to negative 11. So I can go ahead and finish. I'm trying to get X by itself, so I'm going to add 5 to both sides. So it's going to be X is equal to 16, or add 5 to both sides, X is equal to negative 6. So one thing you'll notice here is that, and also in the example, is that when you're done, your answers aren't always going to be the plus and minus version of something, especially when we have other things going on. All right, so the next problem. It's going to be 2x plus 1, all that squared, equals 6. Now, again, the idea is we want to make sure we have the thing squared by itself and then everything else on the other side. And we have that. So we can go ahead and take the square root of both sides. So we have 2x plus 1, because the square root of anything squared is what was squared. And that's equal to the square root of 6, or 2x plus 1 is equal to the negative square root of 6. So then I'm going to go ahead and get x by itself. So I'm going to subtract 1 from both sides. So it's going to be 2x is equal to negative 1 plus the square root of 6. And then, of course, I'm going to divide both sides by 2. So we have x is equal to negative 1 plus the square root of 6, all that divided by 2. Or we can say, we're going to subtract 1 from both sides, so it's 2x is equal to negative 1 minus the square root of 6. Divide everything by 2. So we have our x is equal to negative 1 minus the square root of 6 over 2. Now, just for the ease of writing this, another thing that you could do, as far as formatting goes, that you can kind of say, well, you know what, I don't want to have to write all that out. So I'm just going to write x is equal to negative 1, and the plus or minus version of the square root of 6, all that over 2. Now, when you're trying to get your values of x, you will need to evaluate those if you needed to have a more precise answer. But this is a good way of writing it if we're going to leave it like that. Okay, the next one, when you first take a look at this one, x squared minus 11x, oh, sorry, let's try that again. All right, let's try C again. All right, so when you first look at C, that's x squared minus 12x plus 36 equals 2. Your first thought might be, hey, it's got a middle term. Can't do it, it's got a middle term. But remember, when we're looking at quadratics, we always want to think, is it a special product? And so if this is a perfect square trinomial, it will end up being a binomial squared, which we can work with using the square root method. So let's go ahead and verify it. It has a perfect square at the beginning, it has a perfect square at the end, and it's positive. So far, so good. Now, if I take the square root of each of those and multiply them together, then double it, it should be the middle number. Okay, we're not worried about the sign. All right, so the square root of 36 is 6. The square root of x squared is x. So it's 6x. Double 6x, we get 12x. So we're in good shape. This is a perfect square trinomial. So therefore, it's going to end up being x minus 6 squared equals 2. Now it's a minus because that's a minus. So, all right, so let's go ahead and work this out. We'll take the square root of both sides. So we have our x minus 6 is equal to plus or minus the square root of 2. And then we're going to add 6 to both sides. And the formatting usually has the number and then the square root afterwards. So it's going to be x is equal to 6 plus or minus the square root of 2. All right, let's go ahead and do some of the check your understanding to make sure we're clear on these. Item 6, solve each equation using square root. So it's telling us we're going to be using square roots. That's kind of a hint. So we're going to start off with this, this first one, and it's going to be x squared minus 12 equals 13. And wow. Okay, let's go ahead and just completely undo all that. As I said one thing and wrote something else. Boy, let's try that again. X squared minus 12 equals 13. Those numbers don't even relate that I wrote. Oh well. Okay, so it's going to be x squared minus 12 equals 13. So I'm going to get the thing that's squared by itself. So in this case, it's an x squared. So I'm going to add 12 to both sides. So when I do that, those cancel. I get x squared is equal to 25. So therefore, x is equal to 5, or x is equal to negative 5. I could write that as x is equal to plus or minus 5 if I wanted to. So we're going to look at item number 7 now. Item 7 is x minus 4. That whole thing squared equals 1. So again, that whole thing is squared, so we can take the square root of that whole thing. and we're going to get what's inside, so x minus 4. And the square root of 1 is plus or minus 1. So then I'm going to go ahead and I'm going to add 4 to both sides. So in this case, I have x is equal to 4 plus 1, or I have x is equal to 4 minus 1. Okay, so it's 4 plus or minus 1. And again, my pen must be broken because it is writing things that I don't want it to write. I'm blaming the pen now. Okay, so x plus 1 is equal to 5, and x minus 1 is equal to, or 4 plus 1 is equal to 5, and 4 minus 1 is equal to 3. So our answers are x is equal to 5, or x is equal to 3. All right, and so item number 8. Item 8 is 3x squared minus 6 equals 15. And so, again, the idea is I'm trying to get the item that has the x squared by itself. So I'm trying to get the 3x squared by itself. So I have to add 6 to both sides. So I'm going to end up with 3x squared is equal to 21. And then I'm going to go ahead and divide everything by 3. So I'm going to get x is equal to 7. X squared is equal to 7. At that point, I take the square root of both sides. So I'm going to get x is equal to plus or minus the square root of 7. Item number 9. Give an example of a quadratic equation that has one real solution. So this is one where your number that's going to be square rooted, it's got to be 0. Okay, so you end up with something like x is equal to 0 is what you're going to end up with, because you end up with the square root of x squared and the square root of 0, or x is equal to 0, just the one solution. So the key thing here is that that we have a 0 in the square root inside of that. No real solutions. No real solutions is going to be something where we end up with a negative number. So we have x squared is equal to negative 5, for example. So what ends up happening is when we take the square root of both sides, we end up with x is equal to the square root of some negative number. Well, we don't know how to do that. Okay, so it's going to be a negative inside the radical. And two real solutions is going to be where we end up with something like x squared is equal to 16. And the key is we have the square root of x squared equals the square root of 16. And as long as we have a positive number in here, we're going to be okay. So that ends up being x is equal to square root of 16. X is equal to plus or minus square root of 4, just to finish it out. But we're going to have a positive inside the radical. That's what's real important about that. Okay, so the rest is the practice problems for you to do on your own. Again, if you have any questions, feel free to come to the virtual tutoring weekdays at 3 o'clock on Zoom.